Okay. I see a lot of people responding, we're good. Thank you very much for your feedback. That means that we're up and running, we're live. Please note this session is being recorded so you can view it later on if you need to run for something later. And once again, today we're going to discuss how to build a highly available HyperV cluster with just 2 physical servers and then use Microsoft Cluster storage spaces on top to store our virtual machines. So we try to do a little more relaxed series of events where we take a laid-back approach to showing you the benefits of Virtual Sun, seeing how different expressions and different configurations play depending on where you use it, how you use it, and basically allow you to see where is a good scenario to use it, or basically show you these good scenarios during the events. Now, a little more about myself. I'm StarWind Virtual Sun Product Manager. I'm more than 8 years at StarWind Software in different departments right now. I'm stuck at this position, but so far I like it. Earlier I also worked in IT, so that gives me a total of 11 years of IT experience. Not a lot for today's metrics, but still something. And also you may have noticed me doing the other StarWind technical webinar series. And Anatoly already set the tradition for the top room meetings. My preferred drinks are Scotch and green Mexicans, if I drink at all. Now, small agenda for our today's tap room. First, we'll get the small overview of StarWind features. Then, as a beta, we're going to look at the demo stand, how it's configured, which hardware we use, and stuff like that. Then some flaring tricks is our live demo session. And after all, we'll be doing a Q&A session where I'll gladly answer any of your questions. I'll also try to squeeze in little Q&A sessions in the middle of the event if we have any time when something is initializing, something's loading and stuff like that. Or if simply I see the question, which would be really appropriate in this moment, and I'll just unmute you and you'll be able to ask your question out loud. Right. So a lot of people here already know what StarWind is, and they already use it in some of their environments. But for many people here, there is a question: what is StarWind? What does it do? Where does it come from? How is it brewed? And so the idea behind StarWind is to present the IT world with a fully hardware-agnostic virtual sun, which doesn't really stick to any of the areas. Let's say like single molds stick to their production areas. It may be island, it may be space side, and stuff like that. We try to be agnostic. We try to get a good product wherever we are and whatever we use. You may consider it a perfect drum, if you like. Now, the thing with StarWind is that being virtual simply allows us to get rid of the dedicated storage component. So the idea is that you already have some servers running your virtualization tasks. And with physical sounds, you have to deploy something additional. You have to maintain something additional. While with Virtual Sun, you simply use your local storage to leverage its capabilities up to a whole new level. And, by adding StarWind to the mixture, you get more features, you get more resiliency for your environment, because now the system does not only depend on the local storage, but it also has a backup, which is hot spare, how you call it, of the second SAN. And if you scale out beyond 2 servers, that's resiliency increases and simply gives you more reliability of the system. Now, I see there is one bullet point missing in our presentation, but it shouldn't be an issue. Another reason why StarWind is an interesting approach in the storage virtualization world is that we deploy and try to evangelize a VM-centric file system. So NetApp has done this for ages, but NetApp is more a hardware SAN player rather than a software SAN. And you may think of other vendors who already has a VM-centric file system. But all these approaches are really different only if you have a close look. From the user perspective, it's same storage for his virtual machines, and he doesn't really know how the data is laid out and so on. But here's the thing. StarWind Virtual SAN, LSFS, employs writing of any data sequentially. So even if you have 100% random stream of writes going to the storage array, StarWind converts it into a sequential 64 kilobyte stream and writes it. In parallel, it logs all these write operations in your server's RAM to make sure that when this information is read, the server knows where to read it from. Obviously, this introduces some challenges for fast reading, but these challenges are actually phantom, because if you see the graphs for read-write distributions in virtualized environments, or how the reads are more random or more sequential, and do some tests with real virtual environment, it appears that adding a little flash to the LSFS system really compensates for random reads. And one more thing which allows us to compensate for random reads is that fact we have at least 2 systems in highly available set, so that when we read the data, we can technically read it from 2 locations simultaneously. Well, with writes, we're still limited with a confirmation necessary for every write we do. So basically, you may call it another NetApp waffle, but apart from NetApp waffle, this one does not utilize any proprietary hardware. It doesn't use NVRAM special techniques. It's all Windows-based. It's a simple application which installs inside your Windows Server 2012 R2 and then does this magic. Now, one more thing is that StarWind Virtual SAN allows you to utilize all the modern Microsoft storage features without the need to get dedicated servers or dedicated storage hardware. Like during our today's webinar, we'll see how using just local storage with StarWind Virtual SAN transforms into virtual clustered storage spaces presented from basically from nothing. We use local storage of each server, presented back to the same server, carve out our storage, and then create clustered storage spaces on top. So here, let's have a closer look at today's demonstration stand. Now, we've got just two physical servers, as I mentioned. We don't have any shared storage equipment, no SAS JBoards, nothing. We've got some network cards connecting our servers directly for heartbeat and synchronization purposes. Synchronization, Captain Obvious, we synchronize every single write the virtual machines do to the storage. And heartbeat is the reserve channel, which allows us to determine a possible split brain situation. Let's say this central switch or switch set between the servers has failed, so we add an additional NIC connection between the servers, and they're able to determine, okay guys, we've got a synchronization failure, and let's just check if the second server is online or it is not. Because if the second server is not online, we're good. We just initiate failover procedure, and our hypervisor continues running with just one SAN, and the virtual machines live migrate. If the second server is online, that is called red alert, and in this case, one of the SANs need to be blocked before we proceed with I/O. Otherwise, we'll have two SANs receiving I/O and not being able to synchronize them. And thinking they're synchronized, what they'll do is simply corrupt the data. So we have a really good protection against data corruption, which is our heartbeat interfaces. And you'll see that later in the demonstration part. So this is the configuration we're going to use today. Once we create the virtual devices in StarWind, I'll connect them, and you'll see how we create clustered storage spaces on top. So let's go to our flaring part. Just a second, let me open the remote desktop connections. Okay. Now, let me see. Okay, very good. So this is the StarWind management console. Maybe a really familiar console for you. Some of you may see it the first time. So on the left, we've got our servers listed. Then on the right, we have a property for each server, and we have all the details we may need for them. And we also have a cascade tree of targets, and inside every target we have the ones. So the right part shows us the information about every target and every server, and also has the tabs which allow us to configure the actual server. On the very top we have the new tree. It's still growing. It will be growing more and more, and will have more features, even more than the actual server's tree. With the tree is called clusters. So right now we have a cluster 42 comprised of our two servers today. We already have some devices created in it. And this is an easier way to control your HyperV cluster, because not only it presents everything in a unified view, but also if you go to the actual cluster devices, once you create them, you can connect the devices in your cluster in one click, which is quite useful. Our today's configuration, we have some internet issues. Sorry, it's intranet actually. Second, reconnecting. Right, in our today's configuration, we just use local disks partitioned as GPT and TFS. And this is the storage for our virtual machine, which is later becoming HA, then becoming cluster storage space, and then storing the actual virtual machine. A bit of a layered drink, I'd say, but that still works. That's the whole miracle of virtualization. Even if with that much layers, it gives you fully functional production environment. Just a second. Okay, we're all set. So we have our cluster, and we simply press Create Clustered Storage. Let's give it some name, say Storage 2. Clustered Storage Space 01. It's 11 gigabytes, for instance. Do it thick provisions. And specify the nodes participating in our clustered storage. All right. First one created. And for clustered storage spaces, we need at least 3 disks. So we create 3 virtual disks and continue to the cluster where we'll configure the actual pool and then the clustered storage space. So we'll get one more CSS O2. Okay, 11 gigs. A thick provisioned one. Right, and the third cluster storage. In the meantime, we have some questions. So the last question I see here is from Mr. Guido Mayers. And actually, let me just see if we can find Mr. Guido in the attendees list and try to unmute him so he can ask his question. GoToMeeting panel is not convenient for that number of people. By the way, we have a huge number of attendees today, at least 140 by the time we started, and now this number is still growing. CSS 03. 11 gigabytes. There we are. Okay, so first test and mute on our pilot show. Guido may unmute it if you have a VoIP connection or a headset active. You can ask your question live. Let me know if that's not the case, and I'll just read the question out loud. Okay, I assume that we don't have the audio connection with Guido, so the question was, are the storage spaces for source LANs where StarWind data lies supported or even recommended, or rather basic or dynamic disks? And I would say so far, all of our clients use basic and dynamic disks. We've seen few people using storage spaces with StarWind, but for some reason I don't see a lot of performance improvement with storage space, and I don't see a lot of interest, at least in our community, of using storage spaces as the underlying storage for StarWind. So people still tend to go with the RAID controllers. People tend to go with basic and dynamic volumes. Now, one additional question from Guido is, what is the benefit of a cluster opposed to HA disk? So technically, there is no benefit because it's exactly the same thing. It's just an easier way to create it. If some of our attendees may remember the old way of HA device creation with StarWind, where you had to create an HA device with one wizard. You point to one server, point to another server, select the initialization method, and only then you get the HA device. We changed that a little in version 8, so you now create a simple device, and you can then add an HA replica on the fly. But that appeared to be an appealing option, but some people still prefer to create everything one step. So that's why we created the cluster group, which simply allows you to do that in just a few clicks without need to specify the synchronization channels and all that stuff, because that's already pre-configured on the step of the cluster creation. So this cluster is domain agnostic. It's Windows agnostic. It's simply a configuration share between StarWind on one server and StarWind on the other server. That's all. Right, so now our devices are synchronizing. I could have done this a little quicker, but yeah, looks like something on our test lab switch, because usually that is much, much faster. All right, never mind. While we have some time here, why don't do a little Q&A session right in the middle of the event, since I see a lot of questions anyway. So test unmute number 2. I see an interesting question from Mr. Craig Bowser. So Craig, let me try to unmute you. And you can ask your question out loud. Hello, Craig? Can you hear us? Huh? Craig, we can hear you. Okay. Craig says he's in the loud office, so I better just read it. No problem at all. So the question is, in a 3-node setup, Craig had to do a heartbeat and live migration over a switched environment as recommended by StarWind support. For a 2-node, the direct connections are supported. For 2 nodes, direct connections are supported as long as there is at least one going to a switch. So it needs to be either one going through a switch or a mixture of those. Because if the second server fails, it's going the heartbeat interface on the remaining server as failed. As a result, StarWind is not able to do a proper failover. So that's why we're going through a switch, so we can interface and get no response from it, instead of trying to ping and see that the actual interface is down. Okay, one more question from Julio Flores. Are you using iSCSI storage, or you are virtualizing local storage as iSCSI? We're actually virtualizing local storage as iSCSI. So the devices created here are, here is the actual server where the devices are stored, and this is the local storage of that server. So you can see StarWind, and there are multiple files representing our CSS devices, which I have just created. Now, on the second server, there is the same set of files on the local storage, and these are then presented as a new virtual hard disk to the same server set. Now, the device is nearly finished synchronizing. Let me just go through the questions once again. I think I've missed a few of them. Okay, there is one interesting question here. Is StarWind iSCSI domain agnostic? Yeah, so StarWind itself, so our cluster, StarWind itself, and any of our devices or configurations created so far are domain agnostic. We don't need them to be in a domain, but since we're hyper-converged, the underlying systems need to be joined to a domain. If you are using a compute and storage separated scenario where StarWind runs on different machines, the machines can be outside of the domain. Okay, a question from Lars under Hayden. Is it possible to use a whole secondary drive instead of creating files on the C drive? Yes, it is. In our case, we have one big RAID 1 for our storage. So it's C drive, it's a lab environment. In real production environments, that's actually what we see most of the time. There is a C drive for the operating system, and then there is a D drive for all the iSCSI data. And then there are virtual drives created by StarWind and then provisioned as additional drive letters. Now, a question from Thaddeus Brown. I was wondering why the 2-node version is free for VMware but not for HyperV. I'm a HyperV guy, so I'd love to try this with 2 nodes, but I can't. Well, the thing is that there is a free version for HyperV, but to get it, you need to be an MVP or MCP in the clustering area or virtualization area. So you can, if you're one of the group, then you can definitely inquire our sales or support for an NFR license, and you can test it. Okay, one more question from Tadeusz. What if we're just normal sysadmin and not an MVP or a special certification? Yeah, so it's not only MVP, it's MCP, MCITP as well. So it's not like 100 people in the world who can get this product for free. You can definitely get it with just a basic Microsoft certification. And also you can get a 30-day fully functional trial to see how it works for you. And if necessary, you can definitely expand that trial, or just in the beginning of a test cycle, see how long you need, and double check with the sales guys if you can get the trial for longer. The thing is, with vSphere, VMware Virtual SAN requires at least 3 hosts. So a lot of people who don't have 3 hosts would like to get a 2-node version just to see how their environment can benefit from a SAN. Same thing with HyperV, but we had a free version for HyperV earlier. Right now, we temporarily stopped giving out the free version for HyperV. Maybe we'll come back to this later. And I think there will be a free version for HyperV as well. And also keep in mind that in the upcoming Windows version, you'll also be able to do a shared nothing configuration. So at some point, not only StarWind will be able to do that, at last Microsoft will also allow you to get to that feature. Okay, now question from Field Class. Can we see the bandwidth of the sync? Yeah, the sync bandwidth should be available here in the Task Manager. More details and performance. It's not really big. It should be, yeah, 20 megabytes. Not really good, but it's a SATA disk in this particular configuration. So I would say that it's a tolerable number. Then we have a question from Norman Allen. How many nodes do we need for Hyper-V? Just 2? Yes? Yeah, you're right. For Hyper-V, you just need 2 nodes. I mean, you can go with 1 and directly attach storage, but the minimum viable cluster configuration is 2 servers. You're correct. Also, I mentioned that Windows 10 will have some shared nothing clustering capabilities. My colleague Anatoly just did a webinar yesterday with John Toigo, and they discussed this topic as well. You can watch a recording available on our website if you're interested. Okay, and one more question we have from friend Joseph. Do the servers need to have the same specs? Yeah, it is recommended for the servers to have the same configuration, or if you're doing an asymmetric cluster where one node will be active and one node will be just a failover for some virtual machines, in this case, each particular configuration is discussed and measured. But general idea is to have the storage configured similar way on both servers. So it's an identical RAID set, similar drives used, similar RAID controller used, and similar partitioning used. And of course, the parameters for the above mentioned as well. Then, question I think I already answered. Let's emphasize once again. Jerry Ellis asks us, does StarWind require an Active Directory domain to work, or will it work in a workgroup environment? So the thing is, StarWind itself does not require a domain, but since we're in a hyper-converged world where StarWind is also the HyperV server, in this case, a domain is inevitable, because I've double-checked with Microsoft page on domain detached cluster, and at some point the domain detached cluster mentions that you need to join the machine to domain. So that's still a little contradictory to me. So far we stick with Microsoft recommendations, and best practices for the clusters say that it needs to be in a domain. Okay, give me just 1 second. I just really want to troubleshoot the synchronization thing, because that becomes quite annoying actually. Okay, just double checked. It appeared that while I was on vacation, some black WD drives were swapped with green WD drives. Well, some of us may prefer green color better, but black drives appear to be much faster. So that's why we're seeing such excellent in-gaps performance of our storage. Even though it's one SATA drive, and I still think it's somehow tolerable for 2 parallel operations to slow it down to 20 megs, but I would think about a little more performance from it, not just sustained 20 and less megs per second. So far, one of our devices is synchronized. Let me just quick show you how we connect it to our cluster. I told you that with the cluster entity, we're able to connect our storage in just 1 click instead of going down this route, which you already know, going discovery, going targets, connecting, specifying all those interfaces. No, instead we do this. Connect, and we now go here, go refresh, and boom. Here we have multiple devices connected. We don't have the second and the third CSS devices connected yet because they're not synchronized. But we will do that. We can actually do that now. So the second device has just finished synchronizing. And it's now connected as well. So we check here. And our new disk is also connected here. I'll go to the disk manager and click online and initialize our disks. Okay, and the R will do just fine. Okay, this guy should be finished really soon. Yeah, it's actually a little faster since we stopped the parallel operations. And so that looks much like the green drives. Sorry, that was a surprise for me. Next time I'll make sure we get some SSDs and we see the real storage performance. Now, I see we have some new questions. We have 20 seconds till the drive is finished synchronizing, and I'll commence with the demonstration. So we'll continue with the questions as soon as we finish the clustered storage spaces configuration. So we connect our third device. Okay, now when we're connected, we just online it and initialize it. Okay, now all three drives are initialized and connected on one server. Give me a few seconds to do the same procedure on the second server. Okay. We're all set. Create the volumes. Good. Now we're going to the failover cluster manager, and let me see if all the configuration is updated and we can create a new pool. Interesting. Completed successfully, but we don't see anything found. Let me check. Apologize for that. Okay, let's see what seems to be the issue. And just double check on the second server so we don't get into any. Nope. Looks good here. Now that's something new. Okay, just one thing. I'm wondering if my morning experiments with this configuration have affected it, because it's simply not pulling up the window which it is supposed to pull up. But the good thing is that we have our HE storage available, and even though in this particular case Windows decided not to show us the wizard would like to see, we can still get the storage inside the cluster, then right-click on it, press Add to Cluster Shared Volumes. Actually do that for all three devices we have. And we're now able to use that storage for our virtual machines. I really apologize for the underlying operating system not cooperating today. I think I'll try to get a working set up and running later today and just record an additional part to show you how it is configured. But I'm not sure it's a good idea to troubleshoot it now, because I value your time, and instead I would rather answer the audience questions instead of troubleshooting the lab environment. So let me go one by one here. I've got a lot of new questions in our panel here, and let me just get back to the presentation and pull up the contact information. So a question from Norman Allen. After installing StarWind and configuring the storage, is there an advantage to making a pool versus just adding the disks to the CSV? That is a really interesting and contradictory question. So the thing is that Microsoft claims that they will be expanding the pool and clustered storage spaces capabilities in future. And that's why we added our support for clustered storage spaces, because we want our customers to be able to use native Windows functionality with less hardware and more performance. But for now, I only see maybe 10% or even less of our HyperV folks who use a pool instead of just using multiple CSVs in the environment. Then a question from Todd Gold. Why did we add 3 disks? Because Microsoft clustered storage spaces requires at least 3 disks in the pool to create a clustered storage space. Then a question from Lars van der Hayden. I had a slow sync issue in the lab setup as well, using 10K 2.5 SAS drives. Could it be a cache issue? Technically, yes. In the previous builds, there was a caching issue where the default cache size caused the write performance to drop dramatically after a certain period of time. And after that, we have changed it and actually fixed it. So I think in my particular case, that's just WD instead of WD black RAID 1, which I expected to see. Then let's see further. One more question from Todd Gold. Can you review the base configuration of these servers? Is each server in the target instance a VM or a physical machine? These are 2 physical machines connected with 2 crossover cables and then 2 cables going through the switches. Simple i7 machines, workstation-grade machines with added RAM and added hard drives for StarWind. Okay, let me see if I missed anything else, because there are a lot of questions here. That's already answered. Okay, there we are. Question from Skip Miller. Hi, what are the minimal products from StarWind would you have purchased to achieve an entry-level version of these 2 host design? So that is actually achievable with our base 2-node license, which is StarWind Virtual SEN 1 terabyte. So this allows you to get 1 terabyte of HA space for your virtual machines with just 2 hosts. That's the basic version, and from there you can expand either in terms of capacity or in terms of scale-out capabilities, so adding extra nodes with the same capacity to your existing cluster. Then a question from Jamie Johnson. Would this be suitable for cloud servers for thin clients to game, much like an OnLive server? I'm not familiar with OnLive server. There is a lot of interesting technologies, but yeah, I'm just being honest, I don't track all of them. There may be something in the back of my head about it, but I'd gladly answer this question in an email once I look at the OnLive server. But so far I can just tell that it is suitable for cloud backups. It is suitable for servers doing VDI. And here we have a few more. Carlos Miguel is asking us, how can I have the recorded session because my audio didn't work? I'll provide the recorded session link in the follow-up emails for this event. And as I said, I'll also try to get the clustered storage spaces up and running and do a separate recording of the rest of the demonstration part, like the part which didn't work during the live show, I'll show in a separate video. Then a question from Chris Watley. What is the difference between this and hyperconverged as far as setup? There is absolutely no difference. The only thing is that in a hyperconverged classic, we use cluster shared volumes just on top of the drives, and here we get 3 disks and create a pool of those 3 disks, and then create clustered storage space on top of it. So that adds more resiliency, since there is also redundancy between those, but technically it's still the same 2 servers. Question from Milan Simeonov. Why this is not possible without StarWind software? So this is not possible without StarWind software, because without StarWind software you need a shared SAS JBOD to get the shared storage from, or in case of clustered storage spaces, that's a set of JBODs. And StarWind allows to do that with any storage, be it local storage, iSCSI attached storage, or local PCIe storage, while storage spaces only support SAS, and that's why the use cases are quite limited. Question from Dmitry Pisarevsky. Hello, Windows Server 2012 R2, full support this product. Indeed, sir. 2012 R2 fully supported, not only supported but also recommended. Then a question from Jason Sidak. So you created a JKL drive of the host and presented to the CSV. What happens when that host fails? How are you remapping that drive on the second host? Let me actually show you this. So we have our host 3. We have our disks available as cluster shared volume. And now this cluster shared volume is not a JKL drive anymore. Instead, it's a map point, which is called C cluster storage volume 5. And if any of the cluster nodes fails and the cluster storage is still available, it will be available under this name, not under J or K or L. Then a question from Dmitry Pisarevsky. StarWind supports only 5 12-byte sectors. Not only, we also support 4KN disks now, but that support is only for HyperV, because VMware does not yet support the advanced format. Later on, I think we'll expand that support to VMware as soon as folks confirm that they do support advanced format drives. Then a question from Guido Meyers. Does clustered storage spaces add even more performance to the already big StarWind performance due to caching, etc.? I don't think so, because we have write caching on our layer, and clustered storage spaces may add some performance if we get them to deduplicate, or we enable read caches on top, but I'm not sure about it. I would say that the performance would be similar, because we already implement RAM and flash caching on the very low level, so next to the StarWind core. So I'm not sure adding additional cache will produce a really powerful and useful cascade of caches. Then a question from Todd Gould. So we used up to 60 gigabytes of space to deliver a usable 11 gigabytes on top of RAID overhead. So the thing is that in our particular case, we didn't use a RAID, and the idea was to provision row storage and then RAID it one time with StarWind, so create a network RAID 1, and then on the clustered storage spaces level, that can be a parity, that can be a mirror, so that's not necessarily 11 gigabytes. That's only 11 gigabytes if you're using the mirrored storage spaces. Okay. And a really good question from Todd Gould. Can you simply explain which parts of the whole configuration is handled by Windows and which by StarWind? It seems we created 3 drives on 2 servers, then we were going to cluster through Windows. What would the resulting system look like to a host looking to connect to these drives? So let me show you. We have 2 servers with their local storage. Cluster, the actual failover cluster we see on the screen, is handled by Windows. Local storage is handled by Windows. Then, what is handled by StarWind? StarWind is handling the part where you take the local storage, basically the C drive, and the files in this folder, CSS1, 2, there will be CSS3 somewhere here. Yeah, there it is. And converts them into a disk, which is virtual, but the system understands it as a shared physical disk. So we basically do a shared nothing storage clustering, and StarWind's responsibility here is to get all the I/O going to these virtual disks and route it and synchronize it so that we get real high availability. On top, we can have Microsoft failover cluster running any application using that storage, and that application will rely on not just dedicated shared storage, but on just local storage, which is then clustered and highly available. Now, question from Chris Whiteley. They have white papers for the setup on this. I think we have the white papers, and I'll make sure I follow up with the white papers in the email as well. Then, and let's see, I guess that's all for the questions. No, not really. There is one more question here. Just a second. Sorry for that. The final question we had, is it better to create a RAID volume on each server and then use StarWind to create a clustered volume, or is it better to leave the local storage native, non-RAID, and cluster with StarWind? I think it's better to create a RAID volume and then use StarWind to create clustered storage on top, because that gives you some storage performance improvements on the lower level, and then StarWind is clustering that storage and presenting it as highly available. Because otherwise, let's say we have, for instance, we need to build a high-performance system, let's say a RAID 10. If we just leave the drives as is and then cluster them with StarWind, it will be a RAID 1. So we technically have to build multiple RAID 1s, which will introduce some limitations and inconvenient storage management. Instead, if we create a RAID 10 and then present it to StarWind, and StarWind clusters it on the user side, so actually on the cluster side, like here, you will have one big CSV or 2 big CSVs. Well, each single CSV for a cluster node is recommended because it works faster. This will give you easier management. This will give you more performance. So that's why we recommend RAID first, StarWind using the RAID to create the HA devices. And with that, I think that were all the questions. I'm sorry for the demo glitch today, and I'll make sure I'll include the necessary information in the follow-up emails. I would like to thank everyone for attending our today's taproom meeting, and cheers.